There are many unknown things during the neutrinos. The physics is partially the some oscillations parameters, and we focus on some of the CP-violations and the mass hierarchies in the neutrino software. Both tools are undetermined, the art, and it requires a very precise measurement in the neutrino oscillations experiments. First of all, let's see what is the mass hierarchy. For simplicity, consider two private skies. There's a private eigenstars and mass eigenstars and mixed things matrix that can be written like that, and the corresponding zero mass eigenvalues are written by the M1 and M2. And we assume that the electron neutrino is dominant by the new one, which is that has a mass eigenvalue of M1. So electron neutrino is the new one dominant, and the mu neutrino is the new two dominant. But the mixing angle should be set by the distinctly because sine square theta zeros is rather than the sine square theta zeros, and the theta zero is the less than 5/4. In the normal hierarchy case, M2 is rather than M1, and inverted hierarchy case, M2 is smaller than M1. To describe the mass hierarchy, let's use the ordinary tension of the mass eigenvalue, M minus, M plus. Always M plus is rather than M minus. Yes. Then in the normal hierarchy case, M1 is M minus, and M2 is M plus. And the mass eigenstyles are also assigned to the new minus and new plus. But in the inverted hierarchy case, the M1 is the assigned to the M plus, and M2 is corresponds to M minus. And the bottom mass eigenstyles is such M plus and M minus will be exchanges. So the mixing matrix for this new mass eigenstyles, new ones and the new plus, can be written like that. For the normal hierarchy case is the same because the new minus is the new ones and the new plus is the new two. So theta new and the theta zero is the same, where the theta new represents the mixing between the M plus and the M minus type. And we know that the theta zero is less than the pi over 4 to satisfy the such dominant conditions. Nu is almost a new one like, and the new mu is almost a new two like. So cosine theta t nu is positive from these conditions. But in the inverted hierarchy case, the new e is almost a new one like, but the new ones are assigned to the new plus. So you can assign theta nu, where the theta nu is the m plus m minus the mixing angle is located for the new ones, and the sine theta nu for the new two. So such as position of the cosine theta nu and the sine theta nu the exchanges in the inverted hierarchy case, and the also the second law. So the relation between the theta zeros is a mixing between the M1s and M2. And the theta nu is a mixing of them plus and minus. Such a relation of the theta zero and the theta nu has such a theta zero equal to theta nu minus 5/2 to exchange the sine theta nu and the cosine theta nu. And here there are some of the sine series in the of diagonalism to satisfy the some identity matrix for the limits of the theta nu go to 0. So there are some of the pays in front of the mass eigenstyles, nu1 and nu2. And in this case, we know that the theta 0 is less than the pi over 4 for the such a dominant condition in his is almost nu is almost a nu1 like, and the nu mu is almost a nu2 like. By this relation between the theta 0 and theta nu, we can know that the cosine 2 theta nu is a negative. So the point is the signs of the cosine 2 theta nu is the mixing of m minus and m plus, depends on the mass hierarchy, whether it's a normal hierarchy through the inverted hierarchy. And such a cosine 2 theta nu terms that appears in the Madrid effect. The Madrid effect, effective mixing angles are written like that, where the I is the potential and the theta nu is a mixing of the m plus and m minus in the vacuum. And by solving this equation about the sine scales sort of tilde effective mixing angle, then there's the there is a cosine 2 theta nu terms that appear. for the science case theta tilde. Also, in the solar neutrino, by using such a transfer matrix in the vacuum and the matrix, the phase factors are all averages out. The mixing probability, express the survival probability from the electron neutrino to the electron neutrino can be written like that. All the phase factors are averaged out through the 1/2, and the theta tilde in the sums as applies in the matter factor and the cosine t theta nu. The mixing angles in the vacuums, especially the sum of the mixing between m plus and m minus. By using this formula, the cosine 2 theta nu is the same with the eta cosine 2 theta q's, where the eta is the has a +1 and a -1 for the normal hierarchies and the inverted hierarchies respectively. And the cosine 2 theta effectives the such a mixing angles that represented like that, where the capacity is cosine 2 theta minus a plus sine 2 theta form in the matter effect formalism, and there's a test and a test in here. So we can summarize the survival probability like that, and we can know that there are attached multiplicated in front of the matter effect potentials I. So the matter effect potential is different for the normal hierarchies and the inverted hierarchy. So the survival probability about the energy, because energy is the MSW potentials that are proportional to the energy. So survival probabilities are different for the inverse hierarchies and normal hierarchies. There are the minus signs in front of here. So for the normal hierarchies and the matter effects, the probabilities behaves like that, but in the inverse hierarchies, given like that by this term. And if there is a new matter effect, it becomes like that. And the measurement of the solar neutrino survival that the matter effects solutions and the normal hierarchies. So delta M2 was case becomes positive. So we know that. And there are still the determinations of the delta M31 signs is requires. And the first methods of such determinations of the M31 sign can be possible by the matter effect for the 1 and 3 situation, but the 1 and 3 situation case, M3 is the last compared to with the M2. So energy of the neutrino should be large, so it uses the oxidal neutrinos with the Gibbs case of energy. And otherwise, it is a comparison of delta M13 and delta M23. In the number hierarchy case, there are 1, 2, 3 like that, and we can know that the difference between the 3 1 is rather than the difference between the 2 and 3. But in the inverted hierarchy case, M3 is the lightest mass eigenstype. So M13 is smaller than the M23. And by the using the free analysis of the oscillation data, the past spectrums can distinguish the such M31 and M32 because the pi 32 is smaller than the pi 31. So the past spectrums of the M31 peaks larger than the M32. So if the number hierarchy case, M31 is located in the high frequency. So in the normal hierarchies, the higher peaks appears in the highest energy, but in the inverted hierarchies, M31s, delta M31s are smaller than the M32, so the higher peaks appears in the low energies. So we can determine which is ones that are biggest, M31s and M32s, and we can determine the signs of the M31s. Now we turn to the CP-violations. The oscillation probabilities can be written like that in the 3 private case, where the use mixing matrix and the pi is the pace of the neutrinos, and by using the sum of the identity in the complex analysis and the sum of the identity in the mathematics, we can deduce such neutrino oscillations from mixing probability with the 2 terms. One's the real part and the one's the imaginary part, where the lambda is the defined through the multiplications of the mixing matrix and its conjugate. On the pi IGIs are defined as some of the mixing pauses through the mass difference, distance, and the neutrino energy. And if still we conjugate sort of the CP for this mixing probability for the right hand is anti-neutrino. The second imaginary terms changes through because mixing paces becomes has a minus sign by the CP conjugation. So the point is if we subtract from the first to the second formula, the oscillation probability for the neutrinos and anti-neutrinos, such a difference between the neutrino and anti-neutrinos are proportional to the imaginary part. So, and the imaginary part is related with the CP-violating part exponential I delta CP in the PMNs. So, the difference of the neutrinos and anti-neutrinos relations related with the CP-violations of neutrino softest. And second one I want to mention for the if the alpha is equal to the betas, which means the survival probability or disappearance measurement, the second imaginary parts are equal to 0. So CP violation can be measured by only the transition probability once the alpha is different with the betas in the appearance of the measurement. By using this factor, we can measure the CP violation, but for convenience, we'll define the Jack invariant, which is the CP violation probability is proportional to the such a Jacobian invariant, where the J equal to the sine 1, 2, cosine 1, 2, sine 2, 3, cosine 2, 3, sine 1, 3, cosine 1, 3 square, sine delta CP. On for the Kirk mixing, such a Jack's group invariant is almost 10 minus 5. But in the neutrino case, it's 10 minus 2 times the sine delta CP. So in the neutrino octave, the CP violation can be larger than the Kirk octave. And the such a transition probability in the appearance measurement, the second part is proportional to the Jacob-Slovin invariant, and there are numerous hierarchical and inverted hierarchy sign. So the transition probability origins are different with the different delta CP. There is a probabilities in the y-axis and distance analogy in here, and the starting points of the probabilities are different. And for the normal hierarchy and meta hierarchy, there are different signs. So there are such a two lines for the each origin. And if the sign delta CPs had a different value, the starting points are different. So there are such a many starting points possible depending on the data CP. So the such a mass hierarchies and the CP violation neutrino factors that can be measured by the such a techniques by using the matter facts or the such a transition probability.